Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, hope you're doing well. I'm Callixte. I teach mathematics. Today, we are going to learn together a new lesson. And I'm together with the students of Senior 1. As you remember, last time we were talking about unit number 5. And I think you remember the name of this unit. We call it Leisure and Population. And if you remember very well, last time, on lesson number 3, we were discussing about direct population. But today, we are going to learn a new lesson, which is inverse population. And I think you can get something from there. When you have direct population, of course you have inversely population. I think you remember all the things we discussed about direct population. We were saying if one quantity increases, the other one also increases. Whenever you have two quantities and one quantity increases, the other one also increases. In that time, we say those two quantities, they are directly population. But today's lesson, it is all about inversely population. Every student has to ask him or herself, why? Or how can I understand this? How can I know that two quantities are inversely population? And the object of our lesson of today, I want, at the end of this lesson, each one of you to be able to know what is inversely population, or when two quantities are said to be inversely population. I want to write this down. As the objective of our lesson, I want you, at the end of this lesson, I want you to know every learner has to be able to know when two quantities are said to be inversely, let me write this with a different color because I want you to understand it better. Inversely propositional. I really want you to understand this. When two quantities are said to be inversely propositional. Let's start with a question, and as we finish to work on the activity that I will give you, you will be able to give the answer to that question. The question is, okay, when two quantities are said to be inversely proportional. This is the question that I want every one of you to understand or to have the answer of it at the end of our lesson. You have to ask yourself, when can I know that two quantities are said to be inversely proportional? You see? Let me give you one activity, and then you try it together. We're going to now see the answer of that activity at the end, and then we will be able to understand what is inversely proportional of two quantities. The activity is here. Activity. As you remember, this lesson helps us to understand some other lessons of different subjects, like in physics. when you are learning about motion of object, there is what is very important from there. There are two quantities which are very, very important when you are learning the motion of object. Whenever an object is in motion, you need to look at its speed and also the time or travel time. If an object, for example, if maybe this step as I have it here, if I put it in motion, I let it go in motion like this, I will see how speedy it is and also the travel time it's using to reach at a certain point. So we are going now to use two quantities. Let's have speed as a quantity and also the time as quantity. Those are the two quantities we are going to look at them. And as you remember, we've said two quantities. That's why I want you to keep this in mind, speed as a quantity and also time as a quantity. And at that point, we have two quantities. Keep that one in your mind. Activity is this one. Let's consider the relationship. Consider the relationship between the speed. I want you now to have this, the speed, because I said we need to go with two quantities. We have the speed and the time travel. And time travel, this is also another quantity. You remember we've said the two quantities. We have speed as one quantity and also time travel. And taken by a car. Taken by a car to cover a fixed distance of 320 kilometers. Do you look at this activity? We consider the relationship. It's just the relationship between two quantities. Quantity number one is speed, and the other quantity is time travel. Of course, taken by a car to cover a fixed distance of 320 kilometers. So, look at this table. We have quantity number one, which is speed. Of course, you have to remember which unit do you use when you are expressing speed. Do you remember that? You have to remember which unit do I express speed in. We actually express speed in kilometers per hour or meters per second. And also, we have to look at time. And also time, its unit, let's say, is expressed in hours. This H stands for hours. And also km, kilometers. Now we have this table. Let me put there the data. We have 20. Here we have 16. Here we have 40. Here we have 8. Here we have 80. We have 4. And 160. Here it's 2. You see? This is the table that shows us how speed it's going on with time. Now, you take 20 kilometers per hour to be the original speed. Of course, we've taken these 20 kilometers as the original speed, not mean it's where it is started. Means that car has been moving, and then I have taken 20 kilometers as the original speed. That's why I'm wanting to express this. Now, at the end of this activity, what do you notice? What do you notice when the speed when the speed is doubled. Do you look at this? You are going to work on this activity, and at the end you will say, what do I notice if the speed is doubled? Number B, you will have to plot the graph of speed against time. This is the second thing you would do on your activity. You will, first of all, find out what you observe when you finish to see if the speed is doubled, and also you will also plot the graph of speed against the time. And number 3, you will also describe. You describe the graph. You describe the graph you drew to your friend. To your friend. If you are now maybe together with your friend and you're going to work it together, you will describe it to your friend. But now here, I will actually show it to you how it was supposed to be. We will do it together, and then we see the result. Let me now give you a time. Have a minute and try this out. Okay? You try this out on a paper, and then you work on this. And we will do it together when you finish to try it out. I think you remember how to draw. You'll be having 2 axes. And the one will be for speed, and the other one will be for time. Now have 1 minute and you try it. And when you finish, we're going to do it together and we'll see. Well, as you are trying it out, let's have this part. You remember our lesson is number 4, of course, inversely pollution. Pollution. I think you've tried it out, just on a paper. Let's do it together. You see, now we have y, and we'll be looking for what it may stand for. As you look at this, they have said, what do you notice when the speed is doubled? That is one thing that we would see. Number 2, it's to plot the graph of speed against the time. I want you to remember this. Speed against the time. Let's put speed here. This is speed. And you remember is expressed in kilometers per hour for our case. Okay? And they have told us that we need to draw that graph, and it is against time, and also time for our case is expressed in hours. I told you H stands for hours. Now, when you look at this, these are the coordinates of the point that we are going to plot on our graph here. As you remember, this is coordinate number 1. It is 20 and 16. And number 2, it is 40 and 8. This is 80 and 4. This is 160 and 2. These are the coordinates we are going to put here. And we see the graph of this speed and time. Let's do it together. Let's say here we have 20. Do you see? And here, for example, we have 40. And here we have 60 up to whatever, with the difference of 20, 20. 60, 80, 100. You see? 100. We can continue. 120, 140, 160. No, this is it's for speed. It was supposed to be here, sorry. This is 20, this is 40, this is 60, this is 80, this is 100, this is 120, 20, 40, 60, 80, 100, 120, this is 140, this is 160. And of course, here we have time. It's this one. The time changes. Let's say this is 2, 4 minutes, the 6th minute, the 8th, the 10th, and we don't need this. We will probably draw it on this one, and you can look it well. Now, when you have 20 kilometers, it will be covered within 16 minutes. Within 16 minutes. This one doesn't for sure look clear. We put it here. Here we have speed in kilometers per hour. Here we have time in hours. Let's say, as we have it here, let's say this is 20. I want you to see it clearly. 40, 60, I'm assuming 80, 100, 120, speed, 140, and we have 160. Speed over hours, kilometers over hours. And here it is in the hours. We have the minutes, 2, 4, 8, 16. Let's say this is 2, this is 4, 6, 8, or make it small. Let me divide it into 2 because it has to be many. 2, 4, and then here 6, 8, then 10, then 12, here 14, here 16. Okay? Now, at 20 kilometers per hour, it has been covered in 16 hours. 20 kilometers, 16 hours. It's over here. 20 kilometers has been covered in 16 hours. 40 kilometers has been covered in 8 hours. 40 kilometers in how many hours? 8. It's here. You see? And we have also 8 kilometers covered in 4 hours. 8 in 4 hours. Here. And those we have 160 in 2 hours. 160, it's like here in 2 hours. Do you see? That's why I wanted it to be so clear when you use this graph. As you can see, the points, we are going to join them. This is for 20 and 6. This one is for 40 and 8. This one is 80 and 4. And we have 160 and 2. We are going to plot the graph from the points we've found. When you try it, you will see we get a graph that has to look like this. This is our graph. Okay? And if you remember, what do you notice when the speed is doubled? What do you notice? For example, here the speed was 20. And when the speed was 20, we've used only 16 hours. But when the speed was doubled from 20 to 40, we've used only 8 hours. What do you notice? I wonder you have some seconds and you think about what you notice. Number A. What do you notice? You can observe that if the speed increases because it was doubled, when the speed increases, as you can see, from 20 to 40, time decreases. Time decreases. I think you observe this very well. You see? We've been at 20 kilometers per hour, but we use the 16 hours. When we use the 40 kilometers per hour, the time reduced from 16 hours to 8 hours. This is the first observation of what we have here. What do you notice when the speed is doubled? When the speed is doubled, the time reduces. Now, we are on the second thing. Of course, we've plotted this, the graph on the speed against the time, and we are actually describing what we've got. This is the thing. I want also to explain more. Look, when the speed increased from 40 to 80, they have used only 4 hours. You see? But when they doubled it again from 80 hours per hour, it has gone up to 160, and also the time decreased from 4 hours to 2 hours. Now, if you remember the question we had before, our question was like, when two quantities, of course this is our B, when two quantities are said to be inversely proportional. This one was our question. And as you can see with the conclusion, if we try to conclude by using this part, the answer, this one was our question, the answer is when one quantity increases, when one quantity increases, and I want you also to remember this, which one quantity do we mean? When one quantity increases, can you tell me which quantity is increasing here? Of course, this speed, because it's coming from 20 to 40, 40 to 80, 80 to 160. You see, the speed is increasing. So when one quantity increases, there is something else I want you to remember. With the same rate, what does it mean when there is no? it has increased from 20 to 40. You see? Doubled. From 40 to 80, doubled. From 80 to 160, doubled. You see? We have the same rate. We are doubling, we are doubling, we are doubling, we are doubling. That's the meaning of the same rate we are saying here. So when one quantity increases with the same rate, the other quantity decreases. The other quantity decreases. You see? As the speed has been increasing, the time was reducing. You see? Increasing, decreasing. I want you to fix this. When you go like this, the speed increases. I'm sorry. The speed increases. When the speed increases, time decreases. Time decreases. So then, when these two quantities, when one quantity increases with the same rate, the other quantity decreases, then we say, then this quantity, allow me to clean over here because I hope you finished. Then these two quantities are said to be inversely proportional. Inversely proportional. Inversely proportional. This is actually the purpose of our lesson of today. We wanted to know when two quantities are said to be inversely proportional. I have a homework for you. You want to now write it down, and then with time we will come up and summarize, and we understand again when two quantities are said to be inversely proportional. Before you finish to write this homework, 4 men working at the same rate, you remember this? I have said with the same rate. As you remember this, with the same rate. And you look at this, with the same rate. 4 men working at the same rate can dig a piece of land in 10 days. How long would it take 5 men to do the same job? You see? The second question is 12 tubs can fill a tank in 3 hours. How long would it take to fill the tank if only 4 tubs are working? I want to give you the last formula about this. As you remember, we've said, you remember what you call direct proportional. Directly proportional. It is when y equals k times x. Do you remember this? From direct proportional, we go to inversely proportional. Inversely proportional. Proportionally. Can't even say that. This is when y, of course, is proportional to to k over x. Of course, to 1 over x. When it's written like that, because of x, not k, because when one has been increasing, the other one has been decreasing. Okay? Now, from that example, as you have it over there, you will try it as you are at home, and then I think you will not have any question with this, as long as we would keep to do this. Thank you very much. Have a good time. Bye.